in the next part of the video, and kita dah settlekan example 6A, and for 6B ni saya nak half-half. Maknanya I want to assign this the complete solution. I want you to submit as your classwork submission, tapi there is some part of this saya akan discuss juga kat sini, because saya takut nanti bila you try to solve ada part yang you tak clear. So from the beginning, how to determine the eigenvalue, I want you to solve on your own. Okay, tapi saya nak bagi tahu dekat awak, towards the end, bila you nak find the eigenvalue tu, sepatutnya nanti, you should show all the step daripada beginning, tapi bila you proceed with the step, nanti you akan dapat, sepatutnya the correct one, you come with this factor, lambda plus 1, lambda square minus lambda tolak 2 sama dengan kosong, and when you try to factor this, you akan dapat lambda tambah 1, and here lambda tambah 1 lambda tolak 2 sama dengan kosong. So you nampak tak kat sini, we have two repeating factors, where we have lambda sama dengan negatif 1 2 kali. So we have altogether 3 lambda, 3 factors, tapi 2 repeating factor. So berapa eigenvector that you have to find? Okay, berapa eigenvector that you have to find? Yes, you have to find 3 eigenvectors, even though you negative 1 ni adalah value yang sama. So you have to find 2 eigenvector for lambda equals to negative 1, and you have to make sure each eigenvector tu is not dependent to each other. Okay, so sekarang ni sebab saya nak make sure you clear how to find the eigenvector which is independent of each other, saya akan proceed with how to find the eigenvector for lambda equals to negative 1. Okay, so untuk 2 eigenvector for lambda equals to 2, I want you to proceed on your own, and the step how to find eigenvalues up to this step ni, maknanya step-step sebelum tu you have to buat daripada awal lah. Okay, now I'm going to proceed untuk lambda equals to negative 1 kan. So bila kita cari lambda equals to negative 1, kita akan ganti yang ni sama dengan negative 1, 1, 1, betul? Lambda tolak 1, so we're gonna have plus 1 lah. Lambda tolak 1 kan. Sorry, lambda tolak 1 pula. Kosong tolak 1. Kan ni lambda sama dengan negatif 1. So tolak 1 jadi 1, 1, 1. And this one pun 1, 1, 1. This one pun 1, 1, 1. Darab dengan x1, x2, x3. Then it will become 0, 0, 0. So here we get x1 tambah x2 tambah x3 sama dengan kosong. You buat for second row, third row pun sama. So daripada sini kita nampaklah dia punya relation is that apa? X1 sama dengan negatif x2 tolak x3, betul? X1 sama dengan negatif x2 tolak x3. Okay, so what is the suitable value that we may assign here? Up to you, as long as it satisfies this condition. Okay, so x1 sama dengan negatif x2 tolak x3. Katakanlah saya let x1 sama dengan x1 sama dengan apa ya? Let x1 sama dengan 2. Kalau kita let x1 sama dengan 2, so maknanya negatif x2 tolak x3. Sama dengan 2. X1 sama dengan 2. So negatif x2 tolak x3. Okay, kalau kita let x1 sama dengan 2, maknanya x2 macam mana right hand side kita ni nak jadikan dia boleh jadi sama dengan 2. How to make it equals to 2 as well on your right hand side. Okay, so to make it equals to 2 juga, maknanya kita kena buat x2 ni sama dengan positif ke negatif. Okay, mana pula ni? Okay, x2 ni kena sama dengan negatif lah. Negatif apa? Negatif 1. x3 sama dengan negatif 1, betul tak? Because bila you masukkan, dia akan dapat negatif tolak negatif 1 tolak negatif 1. Yang ni kita punya x2, yang ni kita punya x3. So bila tolak-tolak kita akan dapatlah sama dengan 2. So in this case maknanya if x1 sama dengan 2, then our x2 sama dengan negatif 1, our x3 sama dengan negatif 1. Betul tak? Okay, so I get one eigenvector for lambda equals to negative 1, where I choose it 2, negative 1, negative 1. Untuk satu lagi eigenvector, can I make it a story short? Oh, okay, it's gonna be easy. Dan kita pilih je lah 4, negative 2, negative 2. Is it going to satisfy the condition here? Cuba masukkan. x1 sama dengan 4, x2 sama dengan negative 2, negative 2. Yes, sama. Tapi, what is there any relation between this eigenvector and this eigenvector? Yes, kan? Maknanya 2 kali vektor ni sama dengan vektor ni. So, it will become linearly dependent. Kita tak nak the two eigenvectors are linearly independent. Kita nak dia linearly independent. So, meaning you have to find other value that will make x1 tambah x2 tambah x3 sama dengan kosong. Okay, will equals to 0. Tapi kita tak nak dia macam ni lah. Okay, sebab tadi kita pilih 2 negatif, negatif 1. So, katakanlah this time kita let, okay, we let x2 pula sama dengan 2. So, kalau you let x2 sama dengan 2, maknanya sekarang ni x2 sama dengan 2 sama dengan negatif x1 tolak x3. Okay, so apa yang kita boleh buat? Maknanya kalau x2 sama dengan 2, x1 kita akan sama dengan apa? x1 kita akan sama dengan negatif 1 and x3 kita pun sama dengan negatif 1. Betul tak? Then left hand side akan sama dengan right hand side there. Okay, so in this case, betul tak? x1 sama dengan negatif 1, x3 sama dengan negatif 1, x2 sama dengan 2. So, in this case, kita akan dapat another option. x1 sama dengan negatif 1, x2 sama dengan 2, x3 sama dengan negatif 1. Okay, so kalau kita pilih this option, negatif 1, 2, negatif 1, ada tak dia punya kaitan dengan 2, negatif 1, negatif 1? Boleh tak you factorkan supaya dia menjadi berapa kali ganda of this matrix? Dia tak ada kan? Dia tak jadi macam tu. Kita tak boleh kata the first matrix ni adalah 2 kali this matrix. Sebab dia polarity pun berbeza ni. Negative 1, 2, negative 1. This one, 2, negative 1, negative 1. So, faham tak maksud saya sekarang? Maknanya, we have to properly choose the value of x1, x2 and x3 so that this value satisfy this condition 1. So that it satisfy x1 tambah x2 tambah x3 equals to 0. And another one is to make sure it is not linearly dependent to the previous eigenvector, which is here 2, negative 1, negative 1. Okay, so by having these two, maknanya saya dah bagi jawapan dah pun dekat you all, but I want you to repeat all the steps, write it properly, and show, don't forget every eigenvector that you get, show that it is satisfying the condition Ax equals to lambda x. Okay, and you are to find the eigenvector for lambda equals to 2 as well, and put it in 3 times 3 matrix, and show that the determinant of this x is not equals to 0. Okay, so that will be your first classwork submission for today's asynchronous lecture. Okay. Okay, so now we come to the last part of today's asynchronous lecture. I want to introduce to you three types of matrices. Okay, kita ada symmetric matrix, skew symmetric matrix, and orthogonal matrices. Okay, and orthogonal matrices. Alright, so for the first one, First of all, kenapa kita perlu tahu these three types of matrix? Sebab different types of matrix will produce different types of eigenvalues as well as eigenvectors. Okay, so the first type of matrix is a symmetric matrix. Symmetric matrix ni kita boleh tahu, or we can identify it as an identity matrix when we are able to show that A transpose of that matrix is equals to that matrix. A transpose is equals to A, where a skew symmetric matrix is equals to A transpose, dia sama dengan negative of A matrix, and the matrix is said to be an orthogonal matrix, okay, if A transpose is equals to the inverse of matrix A. Orthogonal is when A transpose is equals to A inverse. Right. So quickly we'll try to solve this example 7. Okay, we'll try to identify, I have a matrix A, B and C. We try to identify matrix A ni apa? Symmetric ke, skew symmetric ke, orthogonal. Okay, remember kalau dia symmetric, then matrix A transpose akan sama dengan A. Kalau dia skew symmetric, then A transpose is equals to negative A. And kalau dia adalah orthogonal, then A transpose is equals to A inverse. Betul ke? Saya pun dah lupa. Betul. A transpose is equals to A inverse. So which is which? Okay, so A ni apa? Cuba kita cari A transpose. Okay, saya rasa semuanya kita perlu cari is A transpose, betul tak? So the first one for A transpose, for matrix A, kita akan dapat negative 3, 1, 5. Okay, and then the second row will be 1, 0, negative 2. And the third, the third column is 5, negative 2, 4. So what you will get for your A transpose is equals to, nampak tak? Sama je dengan A. So confirm this matrix is symmetric. Okay, we try to find B transpose. What is the B transpose here? We find the B transpose here, then we're going to have 0, negative 9, 12. And then we have 9, 0, negative 20. And then negative 12, 20. Kosong. Okay, so is B transpose is equals to B? Tak, kecuali kalau kita letak negatif kat depan, betul tak? Then we can say that B transpose is equals to negative B. Cuba darabkan each of this value with negative. We can have 0, negative 9, 12, 0, negative 9, 12, negative 9, 0, 20. And then negative 12, 20, 0. So maknanya the second matrix is skew symmetric matrix. Okay, skew symmetric matrix. And the last one, C, we try to find its C transpose. So C transpose ni 2/3, negative 2/3, 1/3. Okay, 1/3. And then the second column is 1/3, 2/3, 2/3. And then 1/3, saya dah pening ni. 1/3, 2/3, 2/3. And then the third, this one become the third row, 2/3, 1/3, negative 2/3. So ada apa-apa relation tak so far? Macam tak ada kaitan. So meaning that we have a feeling that this is supposed to be an orthogonal matrix. So if it is orthogonal matrix, maknanya we have to show that C transpose is equals to the C inverse. C transpose is equals to the C inverse. So as your second classwork submission, I want you to show that the inverse of this matrix, find the inverse of this matrix C. Okay, C inverse ni sama dengan apa? And show that C inverse is equals to the C transpose. Okay, so this is going to be your second classwork submission. Basically, it is a revision to all of you for a repetition from your engineering maths 1 punya example tutorial or test or soalan quiz. Okay, many times I ask you to find the C inverse. So I want to refresh your memory. Find the C inverse of matrix C and go extra, show that it is equals to the C transpose, so that we validate that this matrix C is an orthogonal matrix. Alright, okay, so then why we need to know symmetric, skew symmetric and orthogonal matrix? Because eigenvalue for symmetric matrix will be real number. Real number maknanya any number from negative infinity. Kita punya lambda tu adalah from negative infinity to infinity. Kalau dia adalah skew symmetry matrix, then dia punya lambda dia bukan real number. It's not real number. It's imaginary or zero. So sama ada kosong atau imaginary number. You tahu tak apa itu imaginary number? Maknanya bila you kira, you try to factor, you akan dapat something which is square root of negative 1, which is what we call as I here. Okay, we call it as equals to imaginary number. Okay, then kalau dia symmetric, maknanya tak ada masalah. We will get the eigenvalues basically sama type with the one that we have before. Okay, where we can have n eigenvalues. Okay, so for every eigenvalue kita akan ada eigenvector which are linearly independent. Alright, so I'm not going to go far. I'm not going to show you example on how to find the eigenvalue for the case pure imaginary or zero apa semua ni. This is just for your knowledge sajalah, but we won't go far. As long as you are able to understand the difference between these three types of matrix, cukup lah. Okay, then example 8 dan example 9 pun saya rasa is an optional. I'm not going to discuss. Tapi example 8 ni is a good example untuk you cuba cari dia punya okay, untuk you cuba cari dia punya eigenvalue and eigenvector. I can give you answer. Eigenvalue untuk example 8 ni kita akan dapat negative 1, negative 1 and 8. But I'm not going to discuss, and up to you lah kalau you nak. For your further understanding, you can try to solve this matrix, find its eigenvalue, and the correct eigenvalue is negative 1, negative 1, 8. We can see jawapan kita ni correct because 8 tolak 1 is 6. Nampak? 0, 3 tambah 3 is 6. See? Okay, so this is the correct. You may try on your own. Okay, and from kat sini dia ada cerita eigenvalue of orthogonal matrix. Kat soalan ni dia dah bagi tahu this is a symmetric matrix kan. This is a symmetric matrix. So you may try on your own. Okay, you should get lambda equals to negative 1 and 8. And daripada situ find lah dia punya eigenvector and show that again the determinant of this eigenvector is not equals to 0. Alright, example 9, I think I'm going to skip, tak buat. Example 8 ni optional, you may try on your own. Saya bagi dah jawapan. And eigenvalue of orthogonal matrix, this is just for your information lah. Orthogonal matrix yang A transpose is equals to A inverse. Okay, it satisfy this condition for a matrix. Dia punya eigenvalue sama ada real or complex conjugate in pairs. Complex conjugate in pairs maksudnya dia macam ni. Katakanlah you ada lambda u. Lambda u sama dengan dia ada complex conjugate, complex number. Katakanlah 3 tambah 2i. Then there is another lambda that you will get lambda 1, lambda 2u. Definitely you will get 3 tolak 2i. This is just for your information lah. Okay, we are not going to go further on this because I don't see any keperluan untuk you tahu further about this. Just for your information, maksudnya you belajar engineering maths tu ni, you pernah come across with complex conjugate, orthogonal matrix and so on, macam pernah dengar pun cukup lah. Alright, so I think that's all for today's asynchronous lecture. For the last part of chapter 1 part 2, or for the last part of chapter 1, we reserve this for your synchronous lecture next next Sunday, our class. Okay, in next Sunday. Alright class, so I think that's all for today, and don't forget to submit your classwork submission. Kalau siapa yang want to do extra, then you may also hantar your example 8 to me. Okay, your example 8 to me. Alright, so once again, thank you very much everyone, and hopefully okay, today semua orang faham. Satu is, what does it mean by linearly independent eigenvectors? Second, how to determine where the eigenvectors are linearly independent. Nombor 3, how to find the eigenvalues and eigenvectors for 3 times 3 matrix. And finally, number 4 is, you are able to identify sama ada matrix tu symmetric, skew symmetric or orthogonal matrices. Okay class, with that, thank you very much. Assalamualaikum and bye-bye.